Max is here too. Good. Nice. Okay, I'm gonna share my screen. Hopefully. Now the last time I did this, when I'm running like the Google Meet and my Promethean and the little board that I write on, sometimes it gets a little slow, like it lags a little bit. But hopefully this will work. So can you guys give me a thumbs up if you can see the white screen that I'm going to write on? Okay. Good? Awesome. All right, so here we go. Oh. Yeah, it is being slow already, I can tell. Where did the notes go that I made? Oh, man. All right, I'll just rewrite them. Sorry for the delay. Give me a sec here. Okay, so the first problem that I noticed was number 1, and that was when we had 2x plus 3 to the 5th, and we were given ax to the 5th plus bx to the 4th plus cx to the 3rd plus dx squared plus ex plus f, and we were supposed to find d. There's a couple ways you can do this. Some of you might have kind of started off going the long way about doing it. So what do we do with that 5 right there? What does that 5 represent? You can unmute yourselves so that you can participate. What's that 5?
Fifth row of Pascal's triangle.
Yeah, 5th row of Pascal's triangle. Now, as like a little side note, when you make Pascal's triangle, you should be able to recreate this when you need it. I think some people might not have totally watched the video because you were getting the wrong row. So we do not start counting at 1. Some people, I think, thought this was the 1st, 2nd, 3rd, 4th, 5th, and they were using this row, and that's the wrong row. Everything starts with a 0. So this is the 0 row, 1st row, 2nd row, 3rd row, 4th row, 5th row. This is the row you want to use when your exponent is a 5. So what I showed you guys was I typically start by writing out those leading coefficients, and I leave some space in between. And then whatever is listed first, that is going to start getting raised to the highest exponent, which will be a 5. So it's the quantity 2x. And what you have to remember is that the 2 is getting raised to the power as well as the x is getting raised to the power. So keep that in mind. I think some people were missing that fact. And then whatever is listed second, which happens to be a 3, that starts at 0 power and then it increases. So each term, the exponent on the 3 is going to get bigger and bigger and bigger. All right, now we don't have to figure out this entire thing because the problem is just asking for d, and d is in this term right here. So that's the term that is involving the x squared. So of all of these, this will be an x to the 5th, x to the 4th, x to the 3rd. Here's the x squared term. That's the one we care about. We don't care about any of the other ones, so I'm not even going to bother simplifying the whole thing. I mean, you could, but you don't need to. So we have a 10. We have to square the 2 as well. So we'll have a 2 squared, we'll have an x squared, and we'll have a 3 to the 3rd. 2 squared is 4. 3 to the 3rd is 27. So when you multiply 10 times 4 times 27, you're going to get 1080, and then you have x squared. And it was asking for d, which is the thing in front of the x squared. So your answer is 1080. That's what d was. Any questions on that one? Can you give me like a thumbs up if it makes more sense now? Thumbs in the middle if you're still like, I'm not quite sure. Thumbs down if, nope, I don't get it. Okay. All right, then let's go on to number 2. Feel free at any time to just turn your mic on and ask a question, okay? So number 2, same sort of problem. We have x squared plus 4 to the third, and I gave you this kind of setup. And you were supposed to find b. Okay, so so what row do we go to in Pascal's triangle? Yeah, you can hold your hand up if you want, if that's easier. Yep, third row of Pascal's triangle. So going back here, this is the third row of Pascal's triangle. So we're using 1, 3, 3, 1 for our coefficients. All right, now here's where you need to be careful, you guys. The first thing is an x squared. So you're going to have x squared to the highest power of 3. And then that power will decrease to a 2, and then it'll decrease to a 1, and then it'll become a power of 0. And then your other thing is a 4, which will start to the 0 power, but then will increase. Okay, hang on. My pen just slowed down on me. Okay, now we are trying to find b. So that's going to correspond to this term right here. And I have a 3. This will be an x to the 4th. And this is a 4 to the 1st, which is just a 4. That's where the 12 comes in, because you've got that 3 times 4. So b is the exponent, which is a 4. That's your answer to this problem. It's just a 4. Doing all right? Ask me questions if you have questions. That's the whole point of the live session, okay? All right, then we're gonna hop to number 6. Here was the problem, x minus 2y to the 10th, and you were supposed to find a, which is the leading coefficient of the term that involves an x to the 8th and a y squared. So these were the kinds of problems where I gave you, well, we figured out a new formula. The new formula looks like this: n choose r, x to the n minus r, y to the r. That's the formula that's going to allow you to find any single term without having to write the whole thing out. You certainly could do that, but I think it takes a little longer than we would like. So this is often faster. Remember that n is the row, so that's what 10 is here. So I know for sure it is 10 choose something, but I don't know what r is. So I'm just going to put like a box. All right, now x in the formula is whatever this first thing is, which happens to be an x, but it won't always be an x. It just happens to be an x in this problem. So I know I'm going to do n minus r, so it'll definitely be 10 minus something. But again, I don't know what that something is. Now, y in the formula is not just always a y. The y in the formula represents whatever the second thing is inside the parentheses, which in this case is a negative 2y. And that's going to get raised to the r, which is this red box that I don't know what it is at the moment, but I'm going to figure it out because I have some clues. See right here, my big clue is that I need to end up with a 2, a y to the second power. So do you see what should go in this box? Hold up your fingers. What should go in the red box? Yep, a 2. Now look what happens if you put a 2 in all of these. 10 minus 2 is 8. Do you see how you are going to get x to the 8th? And you are going to get a y squared. So it's going to work out. Now what you need to do is just do some work in your calculator. So you got to do 10 choose 2 in your calculator, and you're going to get 45. Okay, hang on. I got some lag. All right, 45. This will be an x to the 8th because of the 10 minus 2. Then here, please don't forget, you have to do negative 2 to the second power. Negative 2 squared is a positive 4. And then you have y squared. But you have to multiply the 45 times the 4, and you're going to get 180 x to the 8th y squared. And the question was asking for a. A is the thing that was out in front, which is a 180. So the answer to the question is 180. Doing okay? All right, we got 2 left. And then if you have any other questions, we can certainly see what you have. Number 7 was x squared plus y to the 10th. And your term that you were trying to find was a x to the 8th, y to the 6th. All right, so again, with our formula, we know that n is 10. That's your giveaway. That is your row of Pascal's triangle. So it's 10 choose something. I will figure that out in a moment. X in the formula is whatever the first thing is. In this case, it's an x squared. And that is going to get raised to the n minus r, so to the 10 minus something. The y in the formula is whatever the second thing is, which happens to be a y in this case. And that is going to get raised to the r power, which again, I haven't figured that out yet. But I've got a clue. This is my clue right up here. See how I need to have a y to the 6th? So what's going to go in the red box? Show me with your hands what's gonna go in the red box. Chris has got it, Andrew's got it, Max has got it. Yep, it's a 6. So all of these are gonna be a 6. Now, 10 minus 6 is 4, but I'm supposed to have an x to the 8th. But do you see how you're gonna get that? Because this will be an x squared to the 4th power. So you will get an x to the 8th. And 10 choose 6, when you type that in your calculator, is 210. So I'm going to get 210 x to the 8th, y to the 6th. And the question was asking what is a, so the answer is 210. Okay, last one. Again, feel free to unmute yourself and ask something if you got a question. All right, here was the problem. Okay, and again, we got our formula. And the first number, the n, is 9. That's the row of Pascal's triangle. The term r, we don't know that yet. X in the formula is the first thing listed, which is a 3x. And that's going to get raised to the n minus r, so 9 minus something. Y in the formula is whatever the second thing listed is, which is a negative 2y. And that's going to get raised to the r power, which we haven't figured out yet. But here's our clue up here. Well, it's kind of lagging, but no. What? Okay, so the clue is I'm supposed to have a y to the 3rd. So what's going to go in this box? Yep, a 3. And if there's a 3 here and a 3 here, well, 9 minus 3 is 6. I will get an x to the 6th, which I'm supposed to have. So now you just go to your calculator. 9 choose 3. You're going to get an 84. But here's where you need to be careful. This is a 3x to the 6th and a negative 2y to the 3rd. you got to remember, and I think people are forgetting this, you have to raise the 3 to the 6th power as well as x to the 6th power. And you have to raise, hang on, you have to raise the -2 to the 3rd power as well as the y to the 3rd power. So you got 84. 3 to the 6th is 729. You have an x to the 6th. -2 to the 3rd is -8. So you have to multiply the 84, the 729, and the -8 all together. And when you multiply them, you're going to get negative. Sorry, pen is being slow again. I'll write it over here. -489,888 x to the 6th, y to the 3rd. And again, the answer is just supposed to be A. So the answer is -489,888. Okay, so that's all I wanted to go over. I wanted to make sure that you saw an explanation of how to do those problems. Is there anything that you guys have questions about? Is there anything that you want me to go over either from previous stuff, or if you've watched today's lesson, do you have questions about today's lesson? You can go ahead and unmute yourself. All right, I got a riddle for you. You know when you have your locker, you got your locker combination? Okay, what's wrong with calling it a combination lock?
It's not a combination, it's a permutation.
Why?
Right.
You got it, why?
Because like once one is taken up, the other ones can't be that number, and there's like an order.
Exactly. So when you have n choose r, how many numbers are on a combination lock? Is it 39? Or 36? Something like that?
It's 0 through 36, or through 39, so it would be 40.
So it'd be 40 numbers. Okay. So if you do 40 choose 3, that would be choosing any 3 numbers. Doesn't matter. Any 3 numbers will open the combination lock. Is that a true thing? No. So like if I get the numbers 1, 4, and 8, can I put those in any order and it'll open the lock? No. So it's not a combination, it's a permutation. So it'd be 40p3. That would give the number of ways to have an ordered 3 numbers in order. So what this will give you is the total number of possible configurations to open the locker. So if you do it in your calculator, this is menu 5-2, I think. Let me get my calculator out. Menu 5-2. And if I do 40, 3, this is how many possible combinations there are. Now, combination is kind of the wrong word though, right? But that's how many different codes could be formed with your locker. And you have one out of that many. Does that make sense? So it really, when they call it a combination lock, not really all that right. It should maybe be called a permutation because the order matters. So if you haven't watched the video yet, that's a little precursor into what you're going to be talking about, what we're doing today, combinations versus permutations. Now, I gotta say, the stuff that we're getting into is gonna get a little tricky. It's always tricky when you get into counting and you get into probability, which we are gonna get into next week. And when we're learning remote like this, I worry a little bit that some of you are gonna get stuck, but then not come to office hours and get help. And I just wanna make sure that you do come to office hours if something's not making sense. Because it won't take me long to figure out another way of explaining it so that you feel better. because there's always more than one way to explain these kinds of things. I'm just, because I'm recording a video, I'm just going to pick one way that I think is going to make the most sense. But if it doesn't work for you, you got to just let me know, because then I'll do it a different way. Okay? Come to office hours, please, 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 please. But at least we've got this live class session. So if next week I notice that things aren't going quite great with the stuff we're learning, then I will address it in the live session like this again. Okay. What else? Anything other questions? Okay. Well, it looks like it's supposed to be pretty nice outside, right? So, and looks like Kate and Abby are outside already. So you guys might want to take a little break if you're not done with your schoolwork. Just take a break, go outside, enjoy the nice sunshine, maybe go for a little walk and stretch and stuff like that. Email me if you have any questions. Come to office hours. I even have office hours tomorrow. You technically don't have class, but you can come to office hours tomorrow if you want. Same time. Okay? So it's 1:40 about, and our session goes to 1:45. But I would say if everything is going well and you're doing all right and you want to get going, you certainly can. Let me just make sure that I saw everyone on here so I can count you for attendance. Okay, I think I did get everyone. Let me just do some screenshots before you go, so I make sure. Also, I am recording this so that if anyone was gone or if you want to go back and look at any of this again, you can. I'm going to stop sharing. Okay, so stick around if you have questions. Otherwise, if you are good to go, then I'll see you later.
Thank you.
Yep.
Bye.
Bye. You. Yep. Have a good one. Hey, Nick. How you doing?
Good. I had a quick question.
Yep.
So, when you're... Hold on. Let me fix